In the previous video, we saw how the heavyweight and lightweight sync instructions could be used for sequential consistency and for a release operation. And we will now see how we can use another sync instruction called isync for an acquire. And the A and B sets consists of all the instructions in the before the isync and after the isync. And the specification of the power architecture is such that no instruction that can cause an exception is allowed to be from the B set is allowed to move to the A set. Is allowed to be reordered with this isync. So if we have a store after this isync or acquire that it is intended to become, if that store can create an exception, then it's not allowed to be moved to before. When could a store instruction cause an exception? It is when the address is invalid. That's one reason. Another would be that it's misaligned for some implementations of the power architecture. Misaligned means it wants to read 4-byte int, write the 4-byte int on an address that is not a multiple of 4. Okay, that can cause a bus error exception on earlier power machines. And if the address is invalid, then that will also cause an exception. That means the pipeline cannot handle the situation and it will ask the operating system to take over, and usually that means terminating the program. It doesn't matter for this course, but in case you are curious, the data that is loaded is into R1 and the address is the sum of these two registers, and the data that is stored is in R4, and well, this address is in R5 plus R6. So now if the CPU can determine that the address is valid, so no exception could happen, then it could be moved to before this acquire / isync, so that doesn't work. But the power architecture does not allow a store to be speculatively executed. So if one has a set of load instructions that must be completed before the acquire, and that store instruction after this acquire is not allowed to be reordered with, then what one can do is as follows. If this case illustrates only one load instruction, but it can be generalized to more. So what we do is to load and then into R1, and then we make a comparison and see if R1 is equal to R1, which it obviously is, and then we have a conditional branch. Okay, so how does that help us? Well, since there is a conditional branch, these two instructions cannot start executing because the architecture does not allow them to be speculated, in particular not the store. So that's a way to create this acquire operation. And if there would be multiple loads, then one can create, well, one can do this a similar thing with each of these loaded values. Okay, so another instruction which we will not look at now, but it's a memory barrier as well, and it's called enforce in order execution of IO, but this is just mentioned for completeness.